Good morning children and welcome to the online teaching session. Students, in the previous classes we have seen about the biotechnology where I have taught you about the enzymes. Okay? Now, today we will see about the competent host. Children, see what I have told you that in case of biotechnology we need few things like we need enzymes, okay? After that, we need host, vector, and the process, okay? That is process of the biotechnology and gene of interest. Okay, out of this, one by one, we will see each and every steps. Like we have already studied this about the enzymes. Now today, we will see the host. And what is the logic, children? That with the help of enzyme, we ligate our host, okay? And inside the host, we have to insert our gene of interest by the process of biotechnology. And then we will get the desired gene. Okay, this whole is the concept. This I have already taught you. Now, today we will see about the competent host. Okay, so our today's topic is competent host. Now children, see what type of host we can use. Number one, we can use prokaryotic cell, and in case of prokaryotic cell, we generally use E. coli. Okay, even we can use eukaryotic cells. Now, what will be the eukaryotic cells? It may be plant cell, okay, it may be animal cell or fungal cell. Out of the fungal cell, plant cell and animal cell, this fungal cell is most common, and in case of fungal cell, we use yeast. Okay. Now children, what we do in case of prokaryotic cells, plant cell and fungal cell, we all know that these cells contain the cell wall. So our first job is to remove this cell wall, and a cell without cell wall is named as protoplast. So to make the cell competent host, we want the cell as to be the protoplast. Okay. So first of all, we'll make our cell, or we'll change our cell, or we will convert our cell into the protoplast, and after that we will begin with the technology. Okay. So this is our first step. That if we have the cell, then we'll make that cell, we'll convert that cell into the protoplast. Next is, so our first step is we have to expose the plasma membrane. Okay, this will be the first step. Now, second step is cell has to be treated with the divalent ions. This is the second step. What is this? To treat the cell with divalent ions. Okay. Now see, to treat the cell with divalent ions, why we need the divalent ions? Okay. Now see, we have already studied in class 11 that our cell is made up of the cell membrane. Okay? And phospholipids are there, proteins are there, and this is the reason that our cell membrane is hydrophobic in nature. Okay? And children, our DNA is negative charge particle. Clear? If it is a negative charge particle, then this DNA cannot pass through this cell membrane. Okay? DNA will not be able to pass through this cell membrane because it is a negative charge particle and the plasma membrane is hydrophobic in nature. Okay? So what happens? We will treat this with a divalent ion such as calcium ion. Okay? If we will treat this with calcium ions, then what happens? There will be the pores. Pores will form. Okay? And because of these pores, the DNA will easily enter inside the host cell. Now DNA is moving in, and once the DNA will move in, this will be the temporary pore and it will be closed once again. So this plasma membrane will recover again. So this is the second important step where we can see that how we can make our cell a competent host. Okay. Next point. Now, after doing this, what we will see before the next point? See, when the DNA molecule will enter into the cell, now suppose the DNA has already gone in, clear? And as the cell will multiply, okay, our desired gene will also multiply. And then by the processes, different processes, we'll purify, we'll crystallize, we will take out these required proteins, whatever we have sent in for the preparation. So this is about the competent host, children. That is, we have to insert or we have to introduce our desired gene, desired DNA into the host body. And the host body should be exposed to its plasma membrane. First point. Second important point, we have to treat this because it is hydrophobic in nature. So we want to introduce the DNA. So we will treat this with calcium ions. Clear? Now, we have to see some methods by which we can insert this DNA into the host body. Directly, we cannot do this. Like while taking the E. coli in hand, we can put the DNA into the E. coli. This is not at all possible, children. Not at all possible. So what to do? We need some methods. We need some techniques by which we can introduce our desired DNA into the E. coli or into the cell. Because now we are not seeing the DNA, we are not seeing the this one, cell membrane or the cell. But we have to do something. So just to do that, we have few more techniques, and these techniques are, let me start with the second point, and that is insertion of DNA or insertion of desired gene into the host body. So what is this? This is insertion of desired gene into the host body. Okay, and in this there are 4 methods. Number 1 is chemical method. Okay, now the concept is clear. That is, if this is the cell, if this is the DNA, we want to introduce this into this. Now it has become competent. Okay, it is ready to accept the desired gene. We want to introduce the desired gene. How we will introduce? We can use number one method, that is called as chemical method, by using some chemicals. Okay, now what to do? In this, protoplast is kept with desired gene in a medium containing PEG. Okay, polyethylene glycol. This is the name of the chemical. What we have to do? We have to keep our protoplast in a medium containing PEG, that is polyethylene glycol. If we will do this, then what happens? The gene will automatically enters inside this. Okay? The gene will automatically insert inside this or enters into the host cell. So what is the result? Gene will automatically enters into the host cell. So this is one method. Okay. Now see the second method. The second method is called as biolistic method or gene gun method. Okay. Now see, second is gene gun, or it is also called as biolistic method. Now children, what we do in this method, we take our desired DNA plus we take a gold. Okay? See, what we do, we'll take the gene, we take the gold. Okay? And we will coat this gold along with the desired gene or desired DNA. It is just acting like a bullet. That's why it is a gene gun method. Okay. So now this red coating is our DNA and this black is the gold. Okay. Now see children, what to do? The size of this bullet is near about 1 to 2 micron. Okay. And with the speed of 1400 feet per second. Okay, see children, this is in the, see the unit. Generally, we do not use this feet as a unit. But here, we will use 1400 feet per second. Okay, so this is the size of our desired gene along with the gold. And with a speed of 1400 per second, we will shotgun. Okay. Normally, we will gunshot or will shotgun this gene into the host cell. Okay. And once it will introduce into it, then the process will go on. Now, here we have to keep one thing in mind, children. That is, the speed should be accurate 1400 feet per second. It should not be less than or more than that. Because if it will be less than 1400, then definitely this particle will not introduce inside. It will fall off here somewhere. And if it will be more than 1400 feet per second, then it may pass through the cell membrane. And once again, our process will be failed. So, while doing this method, gene gun method or biolistic method, we have to be very careful. We have to be very precise with the size as well as the speed. If the size is this, then definitely the speed should be 1400 feet per second. And we cannot increase or decrease the size. The size should be 1 or 2 micron. Okay, so this is our second important term, that is called as the gene gun or biolistic method. The third is electroporation. The third method is electroporation. Okay, I have taught you the chemical method, no? Yes. Third is electroporation. Now see children, what we do in this electroporation, in this we take the cell, okay, in a medium and we pass the electricity with a very high voltage. So what to do? Pass the electricity with very high voltage. Okay, and for a very short interval of time, this is important, for very short interval of time, because if we will not do this, then because of the passing electricity, the whole plasma membrane, it will be removed, nuclear membrane will be removed, but we want to keep everything safe. Okay, so what we do, we pass the electricity for a very short interval of time, and because of passing the electricity, what happens, there will be the formation of pores, and this is called as electroporation. And once there will be the pore, we can insert the desired gene into it. So this is one of the important method. Now, because it has been done because of the electricity, so after some time it will close by its own. As soon as the desired gene will enter into it, it will close by itself. Okay, so this is our third step, electroporation. Then we have one more method, and that is called as microinjection. Okay, so our last method of insertion of desired gene into the competent host is microinjection. Okay, now see children, what we do in case of microinjection. It is same as the process of injection, but it is a microinjection. In this, we can introduce gene in animal cell. Okay, so whatever methods we have studied, all it can be used for adding the desired gene either in the prokaryote, in the plant cell or in the fungal cell. This method we can use for the animal cell, and that is the microinjection. Now children, in this we take the injection like instruments. See, the figure is something like this. This is our holder. Okay, this is our holder, and this will carry your cell. Okay, and now suppose if this is the animal cell, then nucleus and everything is here. Now we have to insert, this is our needle, okay, and this is the syringe of the needle, and it is carrying the desired DNA, and to go for this, there will be one guide. Now this is the guide, okay, just to show the track where this needle has to go, because size you can imagine. Basically, suppose if you are taking ovum, then we are passing the desired DNA into the ovum. Okay, so this is the gene gun method, and this is our needle. No, this is our guide. This is our guide, and with a black pen, as I have drawn the needle, so this will be your needle, and this is our cell, required cell, and this is the holder for the cell. Okay, so what happens? Everything is very fine, very minute with the help of this, and it is done in the presence of, under the microscope. You can say that we can do the micro injection process under the microscope, where we can see all this thing. We used to put one holder. With the help of holder, we hold the cell under the microscope only. Then from this side, we hold this and we pass the injection, and with the help of needle, this DNA enters into the host cell. Okay, so these are the few methods by which we can introduce our desired gene into the host cell. And children, these are the methods in which we have not used vector anywhere. Okay, so into the competent host, we have introduced the desired gene without using vectors. And we saw that there are 4 different methods by which we can introduce, and these methods are chemical method, biolistic method, electroporation method, and the last one is the micro injection. Okay, now this much is enough. In the next part, we will see the next steps of biotechnology. Thank you, children.